Hello guys, and welcome back to another video. So we're still continuing work that we did from the previous video, and in this case we are simplifying using the reversed law 1. Okay, if you recall, I'm gonna remind you once more that for us to simplify this problem, what we have is a to the power of m plus n, and we know that for us to move from here we will end up here, a to the power of m times a to the power of n. If you don't understand this, please go check out the video before this one and you will understand what exactly is it that I mean. But the aim for us to simplify this problem is to go from here to here, and then it will be easy for us to simplify this particular problem. Okay, let's get into it. So for us to simplify this problem, we are going to reverse this 2 to the power of n plus 1 to 2 to the power of n times 2 to the power of n. Basically we're going to do this. In other words, we have to say 2 to the power of n times 2 to the power of 1. The same will be applied here. We'll say 2 to the power of n times 2 to the power of negative 1. All right, let's do it and see how it will work out. So this 2 we're going to drop down times 2 to the power of n. We're separating these two exponents under one similar base, right? So we'll have 2 to the power of n multiplied by 2 to the power of 1. We never write 1. Minus 2 to the power of n. This one remains unchanged. And then at the bottom, we'll have 3 multiplied by, separate these two exponents into one similar base. So we'll have 2 to the power of n multiplied by 2 to the power of negative 1. And then we are going to now factorize, okay? At the top, we're going to take out our common factor, which happens to be 2 to the power of n. When we take out our common factor of 2 to the power of n, we remain with, when I take out 2 to the power of n here, I remain with 2 times 2. Minus, when I take 2 to the power of n out here, I remain with 1. Then at the bottom, I will write everything as it is. I'll write 3 times 2 to the power of n times 2 to the power of negative 1. This 2 to the power of n at the top will cancel out with the 2 to the power of n at the bottom. Then when we proceed, we will have, okay, I'll do this step by step. We will solve what is in this bracket. We'll say 2 times 2, we get 4 minus 1, divided by 3 times 1 over 2. 3 times 1 over 2 should be 3 over 2. Then when we proceed further, we'll have 3 multiplied by 2 over 3. This 3 will cancel with this 3, and we'll have 3 as our answer. You can solve this thing by simply punching on the calculator, okay? From here, you can end here. But to make you understand what is it that we did here, let me just do this. I said 4 minus 1. I know that I'm going to get 3. And that 3 is divided by 3 over 2, right? Now, for me to solve this problem, since I have two divisions, since I have double divisions, I take this one and change it to a multiplication. And when I change this one to a multiplication, it will give me the reciprocal of 3 over 2. The reciprocal of 3 over 2 is the vice versa what 3 over 2 is. So the reciprocal of 3 over 2 is actually 2 over 3. So this means that I will have 3 multiplied by 2 over 3. Then the 3 at the top cancels with the 3 at the bottom, and then we remain with 2. So here we are supposed to remain with 2. I had made a mistake. So that's how you would actually go about solving this particular problem. when you punch on the calculator, you'll still get the same answer. If I say 3 divided by 3 over 2, I get 2, all right? So from here, you can simply just punch on the calculator. Now, let's move on to other stuff. On the next part now, what we're going to do is solve for x, okay? We're going to solve for x using the application of these laws of exponents, particularly the first law of exponents. So let's get into that. Okay, so now we're solving for x, right? Now, for us to solve for x in such a situation, what you need to know is that, right here, if I have a to the power of m is equal to a to the power of n, if I have similar bases on either side of my equation, I have the base of a on the left hand side of the equation and I have the base of a on the right hand side of the equation. This basically means that my exponents are supposed to be equal to each other, okay? So because I have a to the power of m, this exponent of m has a base of a, and on the right hand side I have a to the power of n. This exponent of n has the base of a. It means that for me to solve this equation, I will have my exponents being equal to each other. So my final answer here will be m is equal to n, okay? So that's what we are going to apply here, all right? Because I have on both sides similar bases, it means that for me to solve for x, I will have to equate these two exponents of the base of 2 to each other, okay? Because on the left hand side I have the base of 2, and on the right hand side I have the base of 2. My two exponents are going to be equal to each other, the exponents of these two similar bases, okay? So when I proceed with this problem, what I will have is x plus 1 is equal to 3, right? Because my bases are the same, I make the exponents of these similar bases to be equal to each other, all right? So when I proceed, I will, because I'm solving for x, the aim when solving for x is to have x remaining by itself, all right? So I'm going to transpose this 1 to the right hand side, and when it comes to this side, it's going to change its sign. Since it's positive on the left, it's going to be negative on the right. So when I proceed, I'll have x is equal to 3. On the right, there's already 3, and then I'm taking this 1, taking it to the right hand side. It was positive, so now it's going to be negative. So my final answer will therefore be 2. So my x is equal to 2. All right. And when solving for x, you can always check on whether or not your answer is right by substituting the value that you found of x. And you'll realize that when you substitute that value here, what's going to happen is that the left hand side is going to be equal to the right hand side. Okay, let's do another problem. Okay, here's another problem. So we have 3 to the power of 2x times 3 to the power of x is equal to 9. Now, the first thing that we need to do here, since we are obviously working with law 1, the first thing that we are supposed to do is to put these two exponents under one base of 3, since the two exponents share a common base, right? The exponent of 2x has a base of 3. The exponent of x has a base of 3 as well. So because they are multiplying each other, we're going to put them under one base. So what we will have is 3 to the power of 2x plus x, right? Because when the bases are the same and are multiplying each other, the exponents of those bases add each other, or rather to each other, right? And on the right hand side, we can write 9 in an exponential form, or we are supposed to write this 9 in an exponential form. When I say 3 to the power of 2, I get 9. Now that we are here, it means we need to apply this, because I have on either side of my equation bases that are the same. It means I will make the exponents of these bases to be equal to each other, right? So what I will have is 2x plus x is equal to 2. 2x and x are like terms, all right? Because the coefficient of this x and the coefficient of this x share a similar variable. This means that these two variables or terms are not variables, terms. These two terms are actually like terms. So it means that I'm going to add them with each other, right? I'm going to say 2x plus 1x, and I will get 3x is equal to 2. Again, when solving for x, the aim is to just remain with x alone on one side, right? So because x in this case has a coefficient of 3, it means I have to divide by this 3 on both sides of the equation. So I'm going to divide by 3 on both sides of the equation. The 3 cancels with this 3 on this side. Therefore, my x is equal to 2 over 3. This is my final answer. Okay, that's my final answer. If there's something you don't understand, please feel free to let me know in the comment section. We want to do more problems in the next video, but please guys, kindly like the video, and of course on that red button at the bottom on the right, click subscribe on the channel so that you can get more of such problems being made easy for you. For now, it's a goodbye. See you in the next video.